All right, hi Algebra 2. Welcome back from your winter break. And so we're going to go ahead and start with Unit 5 for this semester. And we're going to be looking at radicals for the most part. This first lesson, we're going to be looking at rational exponents, so exponents that have fractions, or they could also be decimals in them. And how do we use that? So we're going to look at this first example. 3 to what power is going to equal 9? 3 to what exponent equals 9. So you can see the little equation that we have set up there. And so you should know that 3 to the second power is equal to 9. All right, so 3 squared equals 9. Now how can we write the inverse or the opposite using exponents? So 9 to what power would equal 3? 9 to what power equals 3? So we could put some numbers in there to kind of guess and check. Well, we know 9 to the first is going to be 9, right? 9 to the first is 9. We know 9 to the second is 81. It's getting too big. We want it to be 3. All right. Well, 9 to the 0 power, everybody should know is 1. Anything to the 0 is 1. All right. So we're getting closer to 3. So now we're too small. So we can see that we have a number between 9 and 1, and we need it to be 3. And our exponent is 0, between 0 and 1 now. So we know the answer has to be somewhere between 0 and 1 for an exponent. So now we could just kind of start practicing and guessing what number could we put in between 0 and 1 that would get us 3. Well, by plugging in some fractions or decimals, we can see that 9 to the 1/2 power is equal to 3. All right, so that's our fractional exponent. 9 to the half is equal to 3. All right, so we want to remember our exponent rules. So this is all from Algebra 1. And these exponent rules are going to keep coming back, and we're going to use these exponent rules when we talk about the operations. So if we're multiplying or dividing or raising exponents to exponents, what are those rules? And they're going to keep coming back this semester when we get into exponential equations and log equations. So on the left side are the general form, and then on the right side is, with some numbers in its place. So when we're multiplying like variables or like bases, we want to remember that we can add the exponents. So if you look at the example, x to the fourth times x to the fifth, we keep the x, the base, across. We just carry that base, but we add the exponents, the x to the 9. And these operations are going to apply to any numbers that are in the exponents. It could be whole numbers, it could be negative numbers, they could be fractions, decimals. As long as the bases are the same, the operation holds true. We add the exponents. All right, so then the second example is when we have like parentheses and we have something raised, so our exponent's on the outside. And so we want to think of distributing when that occurs. So that exponent that's on the outside, in this case we have this 2 on the outside, it's going to every exponent that's on the inside of the parentheses, and think of, again, distributing. It's a multiplication. So this is where we multiply exponents together, and you can see the example. When we're dividing like bases, then we can subtract the exponents. And typically we want to bring the smaller exponent to where the bigger one is to do the subtraction, and that just will guarantee a positive exponent. If anything that's raised to the 0 power, again, as a review, anything to the 0 power is equal to 1. It doesn't matter what the base is. If you have a 0 in the exponent, it's 1. And then we want to remember that anytime we have a negative exponent, we want to flip it, okay, make it a fraction, and bring that base to the negative exponent. You bring it to its opposite location. And in this case, too, the negative 3 is in the numerator right now. You can see if we put it as a fraction, and we flip it to the denominator, now it becomes 2, the positive 3 on the bottom. Well, when you flip it to the denominator, to make it a positive exponent, you have to leave a 1 on top. All right, and then we can multiply that out. So 2 to the negative 3 is really 1 over 8. Not negative 8, it's 1 over 8. So it turns to a fraction. All right, so then we have this exponent rule with fractions. It says that if you have a fractional exponent, you can convert it to a radical, right? And so you want to see with that fractional exponent where the denominator is going and where the numerator is going. So the denominator goes in as um, the index. All right, so this is called the index. So it's telling you what kind of radical it is. Is it a square root? Is it a cube root? A fourth root? A fifth root? Okay, that's all based off the denominator of the fraction. And then the numerator, that a, becomes an exponent on the base. It can go on the inside, or you can put the whole thing in parentheses and move it on the outside. So I showed two different ways. Sometimes we want to use the parentheses, and sometimes it doesn't help to put the parentheses in there. All right, so I'll give you some examples when we do these problems. So we're going to convert from one form to the other. So we have exponent form, okay, so our fractional exponent. We want to convert to a radical. All right, so we look at the denominator, it's a 3, so that means this is going to be a cube root function. All right, so we're going to put the 3 in the index position, and then the x is our base. Right? And then that numerator, it's a 1. Now, because it's a 1, you don't actually have to put it. It's already assumed there's a 1 on the x right now. So you don't actually have to put the 1 there. But it is there if you want to put it in. All right, the second one, so y to the 3 halves. So now this is a square root. Now, a square root, you don't typically put a 2 there. All right, so you want to remember that a square root is the same written either way. But this is usually, you never see it with a 2 there. Right? It just assumed if you don't put a number there, it is a 2. So kind of remember that. All right, so our base is a y. So we have square root y. Now our exponent's 3. So we have two ways to write this. You can put the 3 on the inside, or you can use the parentheses like I showed, put the 3 on the outside. Okay, either way is okay. All right, the next one, 3x to the 5 4. So this is where we are going to use parentheses, all right, because there's two terms, 3 and x, as our base this time. So we're going to take and write it as a fourth root problem to the 3 of 3x. Okay, so we have fourth root of 3x. Now we've got to raise that to the fifth power. Now, because the whole 3x is being raised to the fifth, this is where we want to use parentheses. All right, so you can't just put the 5 on the x. You have to use the parentheses on this. All right, so the next one, we have a square root, 6x to the fifth. So now we want to convert it to its opposite form. All right, so here we have 6x to the fifth, and that's raised to the 1/2 power. All right, so 6x to the fifth, and that's raised to the 1/2 power. So why is it 1/2? Where's that 1 coming from? Well, the 2 is coming from the square root. Now the 1 is actually coming from, if we were to put parentheses and we put a 1 up there, right, so you can see it. All right, next one, cube root x squared. So this is going to be x, and we're going to raise that to the 2/3. So the cube root, remember that 3 goes into the denominator. All right, so now we have 2xy all raised to 1/2 power. So here we're going to write this as a radical. So this is a square root problem, 2xy. And again, if you want to put the 1, you just put the whole thing in parentheses and put a 1 on the outside, but you don't really need to do that on this problem. All right, and then we're going to go back and write this as a rational exponent. So fourth root 5x, so this is 5x. Since it's two terms, we're going to raise that to the 1/4 power. All right, so now we're going to evaluate each of these. And so we're going to practice converting them from one form to the other first, and then we can go ahead and simplify. So this is where we want to use our parentheses when we can. So 8 to the 1/3, this is the cube root of 8. Okay, it's really 8 to the first, but we don't have to put the 1 there. Now the cube root of 8, you should know, is 2. So you don't even need a calculator for this. Now, you could put 8 to the 1/3 in your calculator. It does have, most of your calculators have a fraction key and an exponent key, and you could put it in there. You should get 2 if you want to double check. 16 to the 5/2, so this is a square root problem. Square root 16. Now we want to raise this whole thing to the 5th, so I'm going to use the parentheses and put the 5 on the outside. So now I can simplify inside the parentheses first. Square root of 16, well, we should all know that is 4. So now I'm raising 4 to the 5th power. Now 4 to the 5th is 4 times 4 times 4 times 4, so this I do want to use my calculator on because I don't know what 4 to the 5th is. So it's going to be 1024. Alright, C, 27 2/3. So again, we want to convert this to a radical first. This is good practice also. Cube root 27. Now I'm going to raise that to the second. So I'm going to put this whole thing in parentheses to the second. So now I'm going to simplify inside the parentheses. Cube root 27, well, that's 3. And now I'm going to raise 3 to the second power. And 3 times 3, that's 9. All right, D, 100 to the negative 3/2. Now, when there's a negative exponent, you have to, with the fraction, the negative has to always go to the top number. It can't go to the bottom number. All right, so we want to keep that negative up on the 3. So that 2 is our square root, so square root of 100. Now we're going to raise that to the negative 3 power. Well, the square root of 100, we should know, is 10. Now 10 to the negative 3, if you remember from the beginning of this lesson, when you have a negative exponent, you want to flip it to the denominator and make it positive. And now 10 to the 3rd can be multiplied out. That's going to be 1,000. So 1 over 1,000. All right, E. So here we have something raised to the negative half. So again, I'm going to put this in, change it to a radical. So this is the square root of 9/4 raised to the negative 1. Negative has to go to the top number. Now I can simplify the square root of 9/4. Remember, that's square root of 9 over square root of 4. You can split it up. It's the same thing. Well, that's the same as 3 over 2 to the negative 1. All right, so the square root of 9/4 is just 3 over 2. Now with that negative 1, you can bring it on the inside. Remember, each of these have exponents for 1, and so this negative 1 can come inside and multiply it to the exponents. So it becomes 3 to the negative 1 over 2 to the negative 1. Now when there's negative exponents, you want to flip them. Since you have a negative exponent on top, that's going to go to the bottom. And the negative exponent on the bottom, well, that's going to go to the top. So the 2 to the negative 1 goes to the top and becomes 2 to the positive 1. And 3 to the negative 1 goes to the bottom, and that becomes 3 to the positive 1. And so we just get 2/3. All right, F, 4th root 562 to the 4th. So this is a problem where you would want to convert it to its opposite form, convert it to a fractional exponent. And you'll see why when we do this. So 562, we're going to raise it to the 4 over 4 power. Well, 4 over 4 simplifies to 1. So we really have just 562 to the first, or 562. Right, same thing for G. So negative 125. We're going to raise that to the 3/3. Well, 3/3 again is 1. And so negative 125 to the first power is negative 125. H, okay, so we have a fractional exponent again, so we're back to that. So I want to convert it to a radical. So square root 36. I'm going to raise that to the 3rd power. Square root of 36 is 6. Raised to the 3rd. So that's 6 times 6 times 6. And so that's 216. All right, I. So we have a 4x squared to the half, so we're going to convert this to a radical. So it's 4x squared onto the radical square root. Well, square root of 4 we know is 2. And then the square root of x squared, well, we should know is just x. Right? Another way you could do this is if you did it separate, so you did the square root of 4, and then, so basically you multiply inside first. So I'll do it down here so you can see it. It's 4 to the half. X to the 2 times half is 1. All right, and now you convert the 4 to the half to a radical and simplify it times x, and then that becomes just 2x again, which is what we got the first way. So there is multiple ways to do these problems. So again, like on J, if you want to bring that exponent in first, okay, like distributing, so it becomes 27 to the 2/3 x to the 6 times 2/3, okay, 6 times 2/3, that's 6 over 1 times 2/3. You multiply across, that's 12 over 3, which is 4. All right, and then you could change the 27 to the 2/3 to a radical. Cube root 27 squared, and we still have the x to the 4th. Cube root 27 is 3. Again, we have the x to the 4th. 3 squared is 9. So we have 9x to the 4th. So you just keep simplifying it in parts. All right, k, negative 8x to the 9 to the 4/3. So again, I'll just bring it inside and multiply it to the exponents. Negative 8 to the 4/3, x to the, okay, that's 9 over 1 times 4/3. Again, if you multiply it across, that's 36 over 3, which is 12. I'll convert this to a radical, cube root negative 8 to the 4th, x 12. Cube root of negative 8, you can have negative numbers under cube roots, not on square roots. But cube roots, it's okay. The cube root of negative 8 is negative 2, raised to the 4th, x to the 12. Negative 2 to the 4th, remember, is negative 2 times negative 2 times negative 2 times negative 2. That's going to get us a positive number. And that's positive 16, x to the 12. All right, and last one, L. So again, I'll do this one more time. This is to the 5/4. Bring that inside. 256 to the 5/4. X to the, we're going to multiply our fractions together. That's 40 over 4, which is 10. Convert this to a radical, 4th root. Raise to the 5th. Bring down that x to the 10. 4th root of 256. So this is where I'd probably want to use my calculator. I have a 4th root. X, there's an x with a radical on your calculator, so you can put a 4 there. 4th root 256. Okay, that's 4. Okay, and you can double check if you raise 4 to the 4th power, it should be 256. Okay, so we have 4 to the 5th power, x to the 10. And then now we have to do 4 to the 5th power. So it's 1024, x to the 10. Right? So that's how you simplify with fractional exponents.